Okay, so welcome everyone to this morning's session, which is the final part of the discrete event simulation module. So in the very first session, you remember we talked about what discrete event simulation was, and you had a chance to try and design a discrete event simulation, which is half the battle, trying to come up with a conceptual model for a discrete event sim. And then in the last session, I can't remember if it was last week or the week before, you had a chance to try out SimPy for actually building one of these things. And you all did really well, actually, putting these models together. So hopefully it's given you a bit of a taste for the fact that you can build these discrete event simulation models actually quite easily using SimPy. It takes a lot of the hard work and puts it behind the scenes, so you don't have to worry about sort of defining all these constructs in a discrete event simulation. So it really makes it nice and quick and easy to do that. However, one of the things I mentioned and that you probably noticed was the way I showed you last time. You end up having to pass around quite a lot of stuff around the simulation. So let's just remind ourselves. Let's go back into one of the first models I showed you last week. So it's just our simple model with patients coming in and they're going to see a nurse for a weight loss consultation. So basically we've got a generator function that models new patients coming into the surgery, and basically we just keep doing this until the model ends. So we essentially call this other function, which describes the journey the patient will take. We get SimPy to process that generator function, and then we sample how long it will be until the next patient comes in, and then we freeze the function in place until that happens. And then in the activity generator, we have another generator function, which is basically to say every time a new patient is created, then request a resource, wait until that request can be met, calculate how long they were waiting, sample how long they're going to spend in this process with this resource, and then freeze until that time has taken place. And we showed you how you can, if you want to have more than one thing happening, so if they then go on to do something else, then we simply have another thing in the body of this function following straight on, and we can have branching paths using if statements and all sorts. So all pretty straightforward, but one of the issues is that even with a relatively simple model, it can get quite messy. So in this case, because we essentially have got the patient generator function, which is creating our patients, that thing is basically going to call this activity generator function, which means that when we call the patient generator, we've got to pass it all of the things that it needs, as well as the simulation environment, as well as all of the things that it's going to need to, in turn, pass on to the activity generator, so that when it then calls that function, it can then pass those things along. And it means you're passing over quite a lot of stuff. So this is a very simple model where you've just got one activity, the weight loss consultation, and one generator, and one queue. And already you've got to pass 4 things into the patient generator. Here you've got to pass the simulation environment, you've got to pass the inter-arrival time, so the patient generator knows how long between new patients coming in. You've got to pass it the mean consultation time, because it's going to need to pass that on to the activity generator to say how long on average patients will spend with a nurse. And you also need to pass the nurse as well, so that can be passed on to the generator. And that's just with one activity. So you can imagine, and when you built your model in the exercise last week, you'll have seen, even by putting in a few extra steps, suddenly you've got lots more that you've got to pass over. Now imagine that you're modeling a process that has 20 or 30 steps and branching paths, so you don't know which way a patient could go down and only have 5 activities, but those 5 activities could be completely different depending on which way they go, which means you're going to need to pass all of that in at the start and then pass it all on to the activity generator, which gets very, very messy. So you can do it this way. There's nothing inherently wrong with doing it, and it's valid to do it like this. But there is a better way, particularly if you're building anything beyond a sort of very, very simple, trivial model, to make life easier for yourself. And that's to use object-oriented programming, which obviously we've shown you a few times now. And it's always difficult teaching this because the kind of models we're going to show you here to show this are actually relatively simple. So it might look like a lot of extra work for little additional benefit other than your code looks nicer. But now imagine scaling this thing up, and suddenly that's where you get the benefit, because it removes the headache of having to try and worry about passing everything all over the place and getting yourself into a bit of a pickle. So that's where the benefit of what I'm going to show you today comes in. I'm also going to talk a little bit today about some other methods of queue activity, so how you pull patients out of a queue, and also looking at how we model unavailability as well. But let's start with the object-oriented stuff. So as I say, so far you've seen the largely non-object-oriented way of putting things together. The better way is to use object-oriented code. So let's have a look to see how we do this with SimPy. So typically, you would split your object-oriented SimPy model into a number of classes. And each of those classes would do something important in your model. And you probably have a fourth one, which I will come on to in a little bit later. But for now, just think about these three classes as being sort of fundamental. So the first class that you want is a class that we typically call G. And basically, this is going to store your global variable value. So all the stuff that before you were putting in at the bottom of your code saying, you know, your inter-arrival time to see the, to come in for the weight loss consultation is this, the mean time you spend with the nurse is this, the probability that you're going to go this way rather than that way is that, and we'd list them all down at the bottom. Instead, what we can do is we can bung all of that into a class, and essentially that class represents our global variable values. And then we can refer to those things at any time, wherever we are in the model, and we don't have to worry about chucking things all over the model and passing it into a function which then passes it on to something else. We can just refer to this class. Now, you'll also remember when I started talking about object-oriented programming back in one of the early sessions, I said there are certain instances where, so normally when you build an object-oriented program, you create a class definition, and then when you want to use it, you create an instance of that class, instantiation, which is where you create an object, which is an example of that blueprint. Now, I also said that there are some cases where you don't do that, where in fact you can just create the class and refer to the class blueprint directly. And this is an example of where you would do that. So you could create an instance of class G, but you don't need to, because essentially it's like a holding bay that's holding all of your information. And so rather than create an instance of that class, we'll just refer to the class itself whenever we need to grab one of these parameter values. And I'll show you how all this works properly in a moment. But essentially, you've got a class here called G that will store all of the things that we'll need across the model in terms of our parameter values. We'll need a class for each type of entity that we've got in our model. Now, maybe we've only got one type of entity. A lot of the models you'll be building, I suspect, will only have one type of entity, so we'd only have one class. So it might be that, you know, we have a class representing patients coming in, but it might be you have different entities. So it might be, in one of the examples we looked at, the surgery, you might have different types of patients and you want to model them slightly differently. In which case you could have a separate class for each of those types of patient. And so this class essentially represents an entity. And what we can then do is we can give that entity a number of attributes. And so you remember when you were coding it last week in SimPy, you were generating a patient ID and then saying this is your patient ID, etc. There may be other things, other properties other than an ID that you want a patient, for example, to have. So rather than having that all pass through the function, what you can do is just say, I'm going to create a patient, and this is your ID, and these are the other attributes about you. And then we can just refer to those attributes wherever that patient is within our model. So again, it speaks to the key advantage of object-oriented programming that allows us to create those instances of those objects and then call on the attributes and methods of those particular objects. It may also be that our entities have particular methods, but at the very least, they'll have some sort of constructor that will essentially assemble all the default attributes for us. So we've got a class representing our global parameters, all the parameter values that we'll need to refer to across all points of the model. And we'll also have a class for each type of entity that we want flowing through our model. We also need a class to represent the model itself. And this class is basically going to host all of the model related stuff. So it'll host the attributes will be things like the simulation environment. That was the thing you had to keep passing around before. So we can host that as an attribute of the model class. We can host our resources, so all the resources we need, rather than passing nurses around between function calls. We can store them as attributes of the model class, and we'll also have a number of methods. And these are some common methods that you want. You'd have a constructor, obviously, to assemble your instance of the model. But this is where we can put our entity generators, so the things that are creating new patients at a certain rate. We'll put that in the model class as a method. We can have our processes as a method, so the activity generator, so where we're telling the model that we want it to patients to go through this series of steps. We can put that in as a method of the model class. And then we can have a run method, which basically tells the model to run for a certain amount of time with certain parameters, etc. So you can see essentially what we've done is we've sliced things up and put them into their boxes, which is basically what object-oriented programming is all about. We've got a box that says over here, I'm going to store all of my global parameters, and I can refer to that at any time. I've got a box or some boxes over here, which represent the entities, the different types of entities that I'm going to have in my model. And then I've got a class over here, which represents the model. And in that, I'm going to put all the stuff that's related to the model itself. So the simulation environment, the resources that are going to be needed, and the methods that are going to get all the interesting stuff going. So how I'm going to generate these entities that I've now got as a separate class, how I'm going to describe the journey they go through, etc. So we've divided this up into those boxes to make it easier and more elegant to be able to write our simulation. So let's have a look at that in practice. So let's go back to our really simple example that we started with last time, where we've just got the single activity model, where we've got patients coming in, they're awaiting their nurse for a weight loss consultation. We've got a single generator of patients coming in here, they're queuing, they wait for the nurse, they have this weight loss consultation, and then they leave the model. So really simple model. We've got our inter-arrival times representing the time between arrivals for people waiting for this weight loss clinic. Our entities are patients, and our activity times are the time that they spend with the nurse in this consultation. So let's think about how we'd divide that up in terms of our object-oriented approach. So we'll think about our three classes. So first of all, we've got our class G, which stores our global parameter values. So here, as attributes of that class, we can store the inter-arrival time between patients coming in. We can store the mean consultation time, how long on average patients are spending with a nurse. We can store the number of nurses that we want in a particular run of the model. We can store how long we want the simulation to run for in simulation time units. and how many runs of the model we want. So all of that global stuff, all these parameter values that we were previously putting in at the bottom of our code, we can store them all in this nice little box over here. Separate to that, we also then want to define a patient as a separate class, and I've called it weight loss patient here because if we were to build out that model, we may want to put in other types of patient that are coming in. So here we've just got a weight loss patient that's got a single attribute, which is their patient ID. So before we were generating a patient ID and then passing that in to the function, here we're just basically saying this patient has a patient ID, and that they're allocated that ID, and they will travel along with that ID throughout the model. And for this particular example, we haven't got any other attributes, although when you come onto the exercise, you may have more than one. And then we've just got a constructor to set that up. And then thirdly, we want our class representing our model. So I've just called it GP surgery model. Here, our attributes are the model type stuff. So we've got our SimPy environment stored as env, and we've just got a single resource, which is a nurse. And so we've got our environment and our SimPy resource, and they're stored as attributes of the model class. And then in our methods, we'll have a constructor to put everything together. We'll have the method that will generate new patients coming in, so our arrivals generator. We'll have our method that will describe the journey they take, which is just waiting for a nurse and then seeing the nurse and then going. So that's our activity generator, and then a run method that will pull all of this together in the right order. So that's how we'll separate it out. Let's have a look at the code for this. So if I go into here, so a lot of this will look familiar because the core principle of having and using generator functions in SimPy still holds, but it's just we've kind of divided it up a little bit differently. So I'm still going to import SimPy and import random up here because I need SimPy to do all of this stuff, and I need random because I'm going to be randomly sampling from exponential distributions in this case. So the first thing I'm going to do is set up my G class. Remember, this is the global variable class. And here is basically just because we're not going to create any instances of this, we're just going to refer to this class and the parameters within it. We're just going to set up our variable values, our parameter values within this. So I've got my inter-arrival time, my mean consultation time, number of nurses, duration of the simulation, and the number of runs. And that means I can very easily just change these things. So if I want to add in a second nurse, I can just change that in the G class, for example. So by storing it here, whenever I want to refer to one of these, I can just say G dot whatever I want. And I don't have to pass this stuff around all over the model. Then we want to think about our weight loss patient, which is our entity. So this is our entity class. So here I define my class. I've called it weight loss patient. And all I need for this particular one is just, they've just got a single attribute. And now we are going to be creating instances of this. So we're going to need a constructor, because remember the constructor assembles instances of our classes to create objects. So here we do need a constructor. And all that needs to be passed in for this particular constructor is the patient ID, and that patient ID is then allocated. So however we decide to generate our patient IDs, this is where it'll be stored in the patient. So the patient now has a patient ID that's a property of them. So that's pretty straightforward. Then we've got the third class, which is the model class. So here I've got a GP surgery model. So here's where all of the exciting stuff happens, basically. So the first thing, again, because this is a class where we're going to be setting up instances of this class to create objects, we're going to need a constructor. So here's our constructor. And here I've just got three things that are being set up. I've got the environment. So I'm going to say the environment now is a property of the model, and it's a SimPy environment. I'm going to set up a patient counter to be 0 because I'm going to use the model to generate the patient IDs that will then be allocated to the patient property. And then I've got my resources. So here I've just got a nurse, which, as you've seen before, you just declare as a SimPy resource. Now here we can see the first instance of the benefit of using this object-oriented approach, because remember, the two things we need to pass into the resource are the environment in which the resource is going to live, and the capacity. How many of this type of resource have we got? So here, normally when you were doing this before, you had this right down at the bottom of your code, and you gave it env because you just defined env as a SimPy environment just above, and you said capacity equals whatever it was. Here we can now refer to these things depending on where they are. So the environment is a property of the model, so it's a property of myself. So grab the environment from myself because I'm an instance of the model class. And the capacity is stored in our global class. Remember, we said that this is where we're storing all our parameter values. So now I can just say the capacity equals G, so I'm calling on the class itself, dot number of nurses. So grab the number of nurses from the G class. Whatever it says in there, that's the capacity I want. So already we've seen that we don't have to pass things around. We can just say, yeah, it's that thing I stored in the G class. So that makes it a bit easier for us. So that's the constructor. The next thing we need is the arrivals generator, how we're going to create new patients coming into the model. And this is pretty much exactly as you've seen it before. So we define it as a generator function. It's still a generator function. That's how SimPy works. I've called it generate WLL arrivals. Because it's a method of a class, I need to pass in self because it needs to know that it's talking about, it needs to create, it needs to know that it's referring to itself. It's the instance that you've created of that class. And then we do all this as we did before. So we say while true to create an infinite loop. I keep doing this until the simulation ends. I'm going to increment my patient counter by 1. I'm going to do that first here, so that the first patient will then be patient 1, which isn't very Pythonic, but I don't care. I'd rather have my first patient as patient 1. And then I'm going to create a new patient. Now here, remember before when we were doing this, if we go back, essentially what we were doing is calling this function, this other activity generator function, and telling Python to run that function. What we're doing here is slightly different. Here, what we do is we say, create a new patient, a new instance of our patient class, which we defined up here. So we were kind of fudging it before, but now we are actually creating a new patient, as in we've created an instance of the patient class. So we've now got a patient object. So WP now becomes an actual instance of the weight loss patient class. And the thing I'm going to pass in, remember up here, I said that we need to, if we're going to create a new patient, it needs to be passed a patient ID, so that the single attribute that we've got can be populated. So I'm going to pass in the patient counter that I've got set up here. And obviously how you'd pass in the ID in a real world scenario would be dependent on what you were modeling. But here we're just basically counting them as the first patient that comes in is patient 1, second patient, patient 2, etc. So I've created a new instance of the weight loss patient, and I've passed in the patient counter. So now that patient is a patient object itself, and it has a patient ID associated with it. Then, just as before, we tell SimPy to process the activity generator to start off the set of activities, the journey that that patient will go through. Only this time, we're now going to pass it the patient. So rather than doing all of that stuff we had to do before over here, where we had to say, okay, and here's the environment, and oh, you'll need a mean consultation time as well. Oh, and you'll need a nurse, and here's the ID. Here, now, we don't need to do any of that. We just say, run the activity generator function with this patient. And the patient's got its ID stored in them. and all the other stuff you need will be stored in the G class, so you can refer to it when you need it. So we don't need to pass any of that around. We just tell it to kick off this generator function with this patient that we've just created. This bit then is exactly the same as we saw before. We then sample the inter-arrival time. So how long until the next patient comes in. Again, we're going to do it for an exponential distribution. But again, rather than having to have passed into this function the mean inter-arrival time, I could just say, oh, yep, that's stored in the G class. So I just say g.wl inter, because up here, that's where I've stored the mean inter-arrival time. So that makes it much easier. I didn't need to pass anything in. I can just refer to the G class. And then, as always, you then just freeze the function in place because it's a generator function until that time has elapsed. So using the timeout. So all the same as before, except you've just got these added conveniences, and that you're actually properly creating a patient here rather than fudging it by getting it to call another function and passing it all the stuff that it's going to possibly need. So that's the arrival generator. Then, of course, we've got the activity generator. So again, this is another method within the model class. And the only thing that needs to be passed in our object-oriented framework is the patient. We just need to give it the patient. We don't need to give it all of this extra stuff. And remember, the patient is carrying with them their ID because we set that up when we created the new patient. So the first thing I can do is just print a little message here saying patient with whatever ID they've got, started queuing at whatever time it is now. Now, don't forget, because this is object-oriented, we need to use the self keyword if we're referring to any elements of the instance of that object. So because environment is now a property, an attribute of the model class, I'm going to be creating an instance of that, then we need to use self to say, yes, when I create an instance of the model, refer to yourself and the environment that you've got within you. That's basically what self is doing. So you need to remember to use that, which if you're doing object-oriented programming, obviously you get into the swing of that quite quickly. Then, just as before, we'll request a nurse. So again, same as before with nurse.request, but again, adding on the self, because nurse is now stored as an attribute of this model class as well. Remember, we set it up in the constructor. And then, just as before, we'll freeze the function until that request can be met. Then I'm going to print the time that the patient finished queuing. And obviously then we can, if we want to do, we can calculate that to the time they spent queuing. I'm not going to do that for a second. And then just as before, we'll randomly sample how long they're going to spend with the nurse. But again, we can use this added benefit that we didn't need to pass in the mean consultation time. We've got it stored in G. So I can just say g.mean consult, and it'll refer to this up here, whatever we've got stored. And so otherwise that's identical. And then again, we just freeze the environment. Freeze the method in place until that time has elapsed. So that's all the same. It's just we're using these added benefits. We haven't had to pass all of this stuff across. We can just pass the patient, and the patient has their ID, and in more complex models we'll have other stuff as well. And anything that's model related, like average time spent in activities, we can just refer to the G class. So the last method we'll need in the model class itself is a run method, which basically tells it the things it needs to do to get this up and running, which if you remember from last time, again, this is stuff that you'd have put at the bottom of the code, which was basically tell it to fire up the arrival generators. We've only got one here, but if you have more than one, you'd fire them all up. Get the environment to process the, in this case, the generate WL arrivals, which is our arrivals generator. Remember, this is now a method within the model class, so we're using self, because it's saying in your own set of methods, you'll see a method called generate WL arrivals, process that thing. And of course, by doing that, by starting that up, that'll then start going through this infinite loop, creating new patients, and then sending them over to the attend WLL clinic method, where they'll go through their processes. And then the only other thing we need to do in the run method here is just now we've started up the generator, the arrival generator, tell the model to run. And if you remember last time, when you told the model to run, you told it how long to run for. And again, rather than passing that around or hard coding it here, we can just say, well, let's refer to the G classes. I've stored it in there as sim duration. So I can say g.sim duration, and it'll pick up 120 time units in this case. So what we've done here is to set up some class definitions. We've got our G class here, which is holding our parameter values. We've got our entity class here, which we've just got one for a weight loss patient, and that's holding a patient ID, so that when we create new patients, they take their ID with them. And then we've got a model class, which has these various methods. We've got a constructor to set up the environment and the resources I need, and in this case also set up a counter defaulting to 0 so that we can create some patient IDs. We've got an arrivals generator, just as we had before, to create new patients actually coming in, only this time we're actually creating new patients. Then we've got our activity generator, which describes the processes they will go through. And then we've got the run method, which says, and this is how all this stuff runs. Now, as you'll be familiar with by now, if we just had all of that, the model would run, and the program would run, and nothing would appear to happen. And that's because all we've done so far is just to define these classes. We've said, this is what a patient is. This is what a model is. This is what a G class is. In order to get this thing running, we're going to need to now create some instances and get this thing fired up. So everything above was just defining our classes and methods within those classes. So now we're going to run it. So we talked about last time how you usually always want to run a model more than once. Any stochastic model should be run multiple times. So all of this stuff that you had to put in a for loop before, if you remember, it was everything. You had to put in the model setup, all of the resources being set up, etc., etc., and all of that had to go in a for loop down here. But of course, the beauty of this is that this is all being stored within our classes now, so we can just instantiate those objects from those class blueprints within the for loop, which makes our for loop much more manageable. So all I've got in my for loop here, I've got that I want you to do this for whatever number of runs I've specified, which again, I've stored in the G class. So I've got my number of runs up here. I can just refer to that. So I can change that easily. All I'm going to do is say, I can have a little message that prints whatever run number it is of however total number of runs I've got. And then this is where the magic happens. We're going to say, right, create a new instance of the GP surgery model class, which is this class here that has the constructor, the arrivals generator, the activity generator, and the run method. So create a new one of those. I'm just going to call mine my GP model. And then all I need to do to get this whole set of processes in motion is just to call the run method on that object. Because by calling the run method, it will then start up the arrivals generator and then start running the simulation, and the arrivals generator will then start creating new patients, which we've defined above. And then they'll be sent over to this function, and that will describe all the things that's happening to them. So that single line here telling the GP model instantiation to run its run method will kick everything off for us. And then I've just got a little print thing here, so I've got line separations. So if I run that, it'll run very quickly, and you can see if I scroll up, so it's gone through each of the 10 runs. So I've got a run number for each run, and then we've just got our messages coming through. So patient 1 started queuing at 0, patient 1 finished queuing at 0, patient 2 started queuing at 2.47, etc., etc., just as you've seen before. So it's all working as it should be. Before I move on, any questions about any of that? Does that make sense?
Sorry, could you just go over the use of self in there? So that's just used when you're describing a class, is that right? And then and it's essentially saying that it's got something to do with the instance of that class each time that you use it.
Yes, that's right. So what you're doing, because obviously in the G class, we don't create an instance of it, we just refer to it. So we don't need a constructor, and there's no sort of mention of self, because we're just going to refer to the blueprint itself. But usually, as with all of our other classes in here, we're not going to, so the class definition essentially is your blueprint that says this is what a weight loss patient looks like. This is what a GP surgery model looks like. But then when we actually come to use it, we'll create a new instance of those things. So every time we create a patient, we'll create an instance of this blueprint. So it'll create a copy of it, essentially. And then by saying self, we're saying, when I say ID, I'm referring to the ID associated with that copy of that object. So the self keyword is basically saying, yeah, refer to the copy you've taken of the blueprint. So it refers to that instantiation of the object, which means you always have to pass as your first parameter value into any of your methods the keyword self, because it needs to basically say it needs to pass the copy of the object. So the class will run it and say, okay, here's the copy of the object that you're going to be doing these things on. And then you use self to refer to, here is the ID, and the ID I'm talking about is the one you've got in this copy of the object. Does that make sense?
Yeah, I think so. I'm going to have to think about it a bit more, but yes, I think I'm getting there with the concept. Thank you.
Yeah, no worries. It's a bit weird at first to think about, but it's it's basically because you're not that your class is the blueprint, and then you're taking copies of that class. So I could have 10 patients, and each of those would be a separate copy of this blueprint up here. And then the self keyword essentially just makes sure that it's saying, when I say ID, don't change it in the class itself, change it in the copy of that class. It's your ID, John. It's your ID, Bob. It's not the ID of the class itself.
Right. So you can keep calling or using that class without overwriting what you'd.
Yes.
Yeah.
Yes, so the class is always your blueprint, and then your, which is why we don't use self here, because there is no instance of the class. It's just the class, and we refer to the blueprint directly, because all we're doing here is just reading some information. So that's okay. But normally you wouldn't do that. Normally you'd have this method, which is where you're referring, you create an instance of that class.
Thank you.
Any other questions?
I presume that if we wanted to then model the impact of multiple nurses in this instance, we could set that up as another loop that says run through our 120 versions of one nurse and then run it with two, or without having to then do it separately.
Yes, exactly so. So you could set up like batches of scenarios that you wanted to test, and then you could have those. Well, you'll see a bit in a minute actually of how you can store different combinations of things. But yeah, exactly that. It makes it much easier to do that.
Okay, thank you.
Any other questions? Okay. You're going to get some practice at this anyway, which you probably guess is coming. So let's just talk a little bit further before you get on to today's exercise. So one other thing that, of course, is very important when you're doing any simulation model, and as you had some practice on doing last time, is to capture results from our model. And we want to capture both run results, so results from each individual run of the model, but we also, because they're stochastic models, we want to run it lots and lots of times, and then we want to, take the average over 100 runs or whatever it may be. So we want trial results as well. The trial represents the set of runs. So if we might have 100 runs of the simulation, and that's our trial. And you had some practice doing that last time. But in the object-oriented framework, we can do this a little bit differently. Now, I think it's going to be easier if I just show you rather than talk through it, because a lot of this probably won't make too much sense. But essentially what we're going to do is to create a new class and then add some other stuff into our existing classes. So in SimPy 002, I've got an example of how you'd want to do this. I've just got an extra couple of imports here I've imported pandas, and I've imported CSV, so I can read and write out CSV. This is the same model, I should say, just with the results being captured. So I've got my G class exactly the same as before. My weight loss patient class, the same as before, except I've added in another attribute. And this attribute is basically going to store how long this patient was waiting to see the nurse. How long did they queue to see the nurse? So I don't need to pass that in because I'm just going to set it to 0. By default, all new patients will have queuing time of 0 because they haven't seen the nurse yet. And then when we want to store, after the patient is queued, we then know how long they had to wait to see the nurse, and then I can update that within the patient itself. So the patient essentially carries around their queuing time with them, as well as their ID now. So they've got an ID, and imagine them with a sort of piece of paper that somebody writes on, you were waiting 15 minutes to see the nurse, and they've got that information on them. And that makes it much easier when we then want to look through how long people spent on average queuing, for example. Now, our GP surgery model class here, again, starts off the same. So we've got our constructor here where we set up our environment, our patient counter, and our nurse resource. But I've added some extra stuff in here to allow me to more easily capture results over the trial. So it would be useful if the model could know which run number it's on. So is it on run number 56? Is it on run number 72? That'll make it much easier for us to be able to store the results for each run. So I'm passing in to the GP surgery model. When I create a new one now, I'm going to give it a run number. And remember, that's going to be easy because when we ran this thing before, we put it in a for loop, and we've got a run number naturally as the index in that loop. So we can just pass that run number into the model. So the model now knows it's on run number 1, it's on run number 2, etc. And I'll show you why that's useful in a minute. I'll also get the model to hold the mean queuing time to see the nurse. So the model will know and will calculate how long patients are spending on average to see the nurse. And I'm going to set up a pandas data frame to store this information. So you're used to seeing pandas data frames now, so I'm just going to call mine results df, create a new one here, and I'm going to set up some empty columns. I've got one that will store the patient ID, one that will store the time they started queuing for the nurse, one that stores the time they finished queuing for the nurse, and then the queue time, the difference between those 2 times. Now, normally, you wouldn't, and for the exercise you'll be doing, you won't need to include start queue and time and end queue time. I've just put those in to sort of demonstrate what's happening. But so normally you'd have your ID and how long they were queuing for each of your queues, essentially. We've only got one queue here, though. So I'm going to set that up, and I'm going to set my index as being the patient ID for that data frame. So that's all standard pandas stuff. Then I've got my arrivals generator function. This is all exactly as it was before because there's no difference to that. We're just getting it to increment the patient counter, create a new patient, send that patient off to that activity generator function, sample the time till the next patient comes in, and then wait. So that's all exactly as it was before. Then we've got our activity generator, and of course here is where we're going to start storing and calculating, storing results, I should say. So this is as it was before, except I'm also just making a note to record the time they started queuing, as we did last week. So before we grab the nurse, what time is it now? And then when I request a nurse, freeze, and then when you get to this bit, that means the nurse is now available, which means we can then record the time they finished queuing for the nurse. And you did that in your model last time. So that's all, sort of what you've seen before. And then this, where you calculate the time they spent queuing as being the time they exited the queue minus the time they entered the queue. Again, you did that before. But this time, I'm going to store that result. Remember, I said the patient is going to store that. They're going to carry that piece of information with them. So here, I've got it, remember, stored as something called queue time nurse. I've set that up as an attribute of the patient. So I'm going to calculate my how long they spent in the queue, and then I'm going to store that in the patient. So the patient now knows and has that piece of information. So I can access the patient's information when I need that piece of information. Then what I'm going to do here is I'm going to add this information to my pandas data frame. And remember that the way we do this with pandas, the easiest way to do it is to set up a new temporary data frame with the information we want, and then join them together with the old one. So here I'm going to set up my a new pandas data frame with a patient ID, and that's going to be the patient ID that's stored with the patient. Remember, the patient has their ID. That's one of their attributes. So grab the ID from the patient. The start time they started queuing for the nurse. Well, I stored that up here. So I'll just bung that in. The same with the time I finished queuing for the nurse. I stored that up here. And then the queue time, well, the patient, I calculated that up here, and then I gave that information to the patient. I stored it in a little variable called queue time nurse. So I can now grab that from the patient. So how long were you waiting? And they can give me that information because it's stored in queue time nurse. So I've put all that into a data frame. So this now is a data frame that represents this patient, the time they started queuing for the nurse, the time they finished queuing for the nurse, and how long they spent, so the time difference between those things. I'm going to set my index to patient ID to make sure it's the same as the thing I'm joining it to. And then, as you've seen before, I then add it to my main data frame, which is stored as an attribute in the model class. Remember, I've got the results data frame is stored as a property of the model itself. So I'm going to say grab that data frame here, grab results df, and I want you to add to that this little temporary data frame I've got here, which has all of the information about this particular patient. So I've added this patient's information to my data frame that's stored against the model. Then this is exactly the same as before. How long will they spend with the nurse? And then freeze until that time elapses. That's all identical. So what I'm also going to need, as well as, so I'm now storing how long each patient spent waiting. And I'm storing that, so the patient's got a copy of how long they spent waiting, and I've got a data frame that's the model is storing, that's basically going to every time a patient comes through, their information will be added to that data frame. So I'm keeping a record of how long each patient that comes through the model is waiting. But I'm also going to want a method to calculate the outcomes that I want. So in this case, I want to find out what the mean queuing time is for the nurse. So I've set up a little method within the model here that's just called calculate mean queue time nurse. And basically all this method is going to do is just calculate the average of the queue time nurse column of the pandas data frame. So it's not a particularly complex method. But you may, of course, want to do more fancy things with your results than just taking the mean. So all we're going to do, I'm going to calculate, and remember the beauty of pandas is I can use these handy little methods. So I can just give it a column and say, take the mean of that column. So I want the mean of the queue time nurse column. And remember, the data frame is stored within the model class. So itself grabbed me the data frame that this copy of the model class owns. Take the mean of it, and then store that as the mean queue time nurse attribute in myself. Remember, when we set up the constructor here, I said I've set up an extra little parameter value attribute here called mean queue time nurse. It's going to start off at 0, but that's going to hold the average queuing time for the nurse across the model. So that's where that information will then be stored. So we've got the model that's holding a data frame that contains all of the individual entries for each patient, and then also a method that's then going to calculate the average queuing time for the nurse, and that's going to be stored as an attribute of that model. So that's a separate method. And then I've got another method that I've written down here, again, another method of the model class that basically just says write these run results to the to file, because we said last time that's a really easy way that we can do multiple runs and then take average results over a trial. We can just write that stuff out. So we'll write the results of this run out to a file. so that when we've done 100 runs, we can then read back in that information and then grab whatever information we want from that. So here, this is all as you've seen before. I'm just going to open my results file. I've just got my trial results.csv. I'm going to open it in append mode because I don't want it to overwrite the file every time a new run comes along. I want it to add it to the end. I'm going to set up a new CSV writer, and then I'm going to write to my results, which in this case is just going to be the run number and the mean queuing time for the nurse for that particular run. So remember I said this time I'm going to pass in the run number to the model class. So every time the model runs through, it'll know what run number it's relating to. So it can then use that here and say, okay, on run number 3, the mean queuing time for the nurse was 12 minutes. And that's what it's going to store. And then it'll write that to the file. Then we've got our run method as we had before. Again, we do exactly the same things as we did before. We tell it to start up the arrivals generator and we tell it to run the simulation. But we've got an extra couple things that I wanted to do. So at the end of each run, so after this, it'll have completed 1 run of the simulation. So we've got it set up to 120 time units. My time units represent minutes. So it's going to run for 2 hours of simulated time. After that's done, after we've modeled 2 hours of our surgery, then I want it to do these things as well now. So I want it to calculate the run results. So remember, I set up a method up here saying calculate the mean queuing time for the nurse. So once the run is finished, I'll just call that method, and that method will look back over the data frame, look to see how long each patient spent, and took a mean of all the patients in the model, and then it'll store that as the mean queuing time for the nurse. And then I want to call the write run results method, which will then write those results out to file. It'll write the run number alongside the mean queuing time that it's just calculated. So I can just call those methods. Now, of course, I could run those things separately, but we're doing this object-oriented. We should have separate methods that do these things for us, and then we just call those methods. Now, what you'll also see here is I've added in an extra class. So this, we didn't have this class before. And this class is basically going to calculate the results across our trial, so across our batch of runs. So if we've got 100 runs of our simulation, this class is going to sort out how it's going to calculate results over all those 100 runs. And I'm going to store that as a separate class. I've called mine trial results calculator, call it whatever you like. I've got 2 methods. I've got a constructor method here. All the constructor is going to do is set up a new data frame, which I've called trial results df, and that's going to store the information we want about the trial. And then the main method here is going to be the one that reads in the trial results and prints them out for the user. So here I'm just going to print them out to screen. Obviously, you may want to do different things, but remember, we're already writing up here. Each run result is being written to our CSV file. So what we can do here is the first thing I can do is just read in that file, because once the trial is over, all the runs have completed, I can then read back in the results from each run in trial results.csv. And remember this handy little shortcut on pandas, which allows us to read that CSV in a single line of code and automatically dump it into a pandas data frame. Really nice and easy. So that's now stored in our trial results data frame, which is an attribute of this class. And then all I'm going to do is I'm just going to take the average mean queuing time over all the runs in this case. So I'm just going to say, grab me the mean queuing time column for each of my 100 runs, take the average of that column. So here I'm just saying, grab me the data frame that I've got stored in this class. And that now has this information that we've read in from the file. So grab that data frame and take the mean of that column. And then I'm just going to print that out for the user. So it'll tell them what the mean queuing time for the nurse was over the file. So that's all of the bit above. And then remember, now we need to get things going. I've just got a little extra bit here where I'm just going to set up the trial results file for the first time. So when we first run this code, when it gets down to here, it'll create this new file, or if one already exists of that file name, it'll overwrite it. Because I'm putting it in W mode, which means sort of write. So if it doesn't exist, create it. If it does exist, start from the beginning. And I'm just going to use this to put in some column headers. So I've got a column called run and a column called mean queue time nurse. I'm just going to write that out to file first of all, before I start with all this stuff up here. And then I'm just going to run the model in exactly the same way as I did before. So for however many runs, print the run number, create a new instance of the model class. The only difference here is that I'm passing in the run number. Remember, we changed it now so that when we create a model class, it's going to expect, when we create a new instance of the model class, it's going to expect the run number. So I'm going to give it a run number, and I'm just going to take that from whatever index. So the first one will be 0, the second one will be 1, the second one will be 2, the third one will be 2, etc. So give it that. That GP model instantiation now has the run number, and then just as before, run the run method, which will kick everything going. Once it's done those 100 runs, then I just want to do a little bit after to get the trial results. And remember, we've created a class up here called trial results calculator. So I'm going to create an instance of that class, and I'm call it imaginatively my trial results calculator. Could of course call it anything. And then I'm just going to call the print trial results method in that class. Sorry, in that object. So it'll then do this thing here where it'll read in the trial results that we've stored over the course of the runs. And then it'll take the average and print it out to the user. So if I run all that, let's just run that. So now when I run it, it's gone through our 100 runs, and at the end, it said the mean queuing time for the nurse over the trials, over all 100 runs, was 15.72. And if I were to run that again, you'll see the results shouldn't differ too much. There we go, 15.18. It's going to be more stable now because we're not just taking results over a single run, we're looking at across all 100 runs. So basically all we've done to get in our trial results is we've added an attribute to the entity class, so in our case, the patient, saying, I'm going to tell you how long you spent queuing for each of these things. It's only the nurse in this case, but and I want you to hold on to that information. In the model class, we're going to store, I also want to give it a run number so it knows what run number it's on. And it's going to store the mean queuing time across all patients for a particular run. And it's also going to have this data frame which stores the information for a particular patient. The generator arrivals class method will be exactly the same as before. The activity generator will be mostly as it was before, except this time we're now going to calculate the time that we want. So we store that in the patient. We say, this is how long you're waiting. Give that to the patient so they can store that information. And then we ask the patient for that information to store it into our data frame. And then I've just added in a couple of extra methods here. One that will calculate the mean queuing time for the nurse, and another one that will write the results of this run to file once each run is completed. And then a couple of extra things that I've added onto the run method to call those new methods. And then an extra class here that will basically sort out what I want to do about the results over the trial as a whole. And here I've just got a simple method that basically reads in the trial results that we've been saving to file, and then takes the mean and then prints that out for the user. And then all we do down here is exactly the same as we did before, except I'm just going to add in this little extra bit to create my new file. So I'm going to put in some column headers. I'm going to run the model in the same way as I did before. The only difference being I'm going to pass in the run number so it knows what run number it's on. And then I'm going to create a new instance of my trial calculator class and then call the print trial results method. Any questions about any of that?
Similar to before, I presume we could have, if we wanted to keep each, instead of overwriting that trial results CSV each time it's run, we could have then set the global class a time-stamped CSV name.
Yes.
And then called it in, and then used it in both those instances.
Yeah, absolutely. So yeah.
Would we then do the same for recording the settings in that global class if we've then changed them on various runs, so that we could go back and look at them.
Yeah, so that's a really good point. So in reality, you probably wouldn't even. So this is better than what you had before, but a good practice would still be not to hard code these numbers into your Python code. So what you ought to have is a parameters file that you read in, and you change the parameter values in that file, and then essentially the G class would read in that file and then store these results against it, these parameter values against it. So yeah, that's what you'd probably do in practice.
Would we then kind of potentially create a second file, or append this one with the parameters that had been used if we've then been tweaking them to get to an optimum model?
Yeah, so what you might want to do is, so if you were running it different sort of scenarios, yeah, probably be good practice to maybe in your results file have a line that basically indicates what the parameter values were, so you know what particular parameter values were used for those to generate those results.
Okay, thanks.
Yeah. Any other questions?
Dan, I've been Googling around because I looked at the CSV output file and it's got carriage returns in it. With the open trial results CSV function, if you add the parameter new line equals double quotes, then it takes all the spaces out.
On what bit? Sorry,
when you say with open trial results.csv,
here, yeah.
In there's a parameter you can use called new line equals double quotes, so nothing.
Yep. Mm-hmm.
And that takes all the carriage returns out of the CSV file. So when you open it up, it doesn't go header space new data space data space data.
Right, I see. Okay.
So when you open it in a spreadsheet, you don't have loads of gaps between each line.
Right. Yeah. I mean, it doesn't. Maybe LibreOffice is better, but when you open it in LibreOffice, it doesn't do that.
Doesn't it? It does.
No.
If you open it in Excel, it does.
Well.
Maybe that's a limitation of Excel.
Yes. Of course. Yeah. I mean, it's yeah. I mean, I would generally recommend you open your CSV files as in a text editor. Really.
In a text editor, it does the same.
Oh, really?
Yeah.
Maybe it's a Windows thing then. It works fine on Linux.
Leave Windows alone.
Yeah, okay, but thank you for that. So it sounds like that might be useful if you are getting that problem. That will sort it. Brilliant. Thank you, Richard. Any other questions? Okay, right. I've been talking for a long time, so it's time for you to do an exercise. I'd recommend before you move on to the exercise that you take at least 5-10 minutes, stretch your legs, because it's going to be a long exercise. Oops, why is that frozen? There we go. So this is going to be your task. Now, I originally allocated you 2 hours to do this. We haven't quite got 2 hours, and I think I may have been overestimating it slightly. Aim for about an hour and a half-ish, but I will be floating around and I'll keep an eye on how well you're going. But it may take you a while to do this, and I want you to do this in groups as well. So basically, you're going to write an object-oriented version of this model. Now, you'll probably recognize this model because it was one of the ones that I showed off at the last session in the SimPy 3.py file, which is where we've got patients coming into the ED. They're queuing for registration, which needs a receptionist. They're then queuing for triage, which needs a nurse. And then there's a branching path where 80% of them, so most of them go off, stay in the ED, and they wait to see an ED doctor. But 20% of them wait to see an ACU doctor. They get an assessment in the ACU. So relatively simple model with 4 activities, but it's a branching path, so each patient will only go through 3 of these. And we've got all of the information here. We've got, on average, people arriving every 8 minutes into the ED. They're taking, on average, 2 minutes to be registered, 5 minutes to be triaged, 30 minutes to be assessed in the ED, 60 minutes to be assessed in the ACU. Remember, these are just averages. 20% probability of going to the ACU. We've got 1 receptionist, 2 nurses, 2 doctors, 2 ED doctors, and 1 ACU doctor. And I want you to run this model for 48 simulated hours. after a 24-hour warm-up period. Remember, we talked about warm-up periods last time. That's being the period of time for which you let the model run, but you don't collect any results, so as to let the model go from being in an empty state to something a bit more approaching reality. And the model should be run 100 times. So I want you to create that model, but do so using an object-oriented framework, as I've outlined this morning. You're going to need to ensure that the model stores the queuing times for each queue for each patient. So don't worry about, so in the example I just showed you, I stored the time they started queuing and the time they ended queuing, as well as the total queuing time. Don't worry about doing that, just store the total queuing time. But you're going to need to store it for each of the queues. So the queue for the receptionist, the queue for the nurse, the queue for the ACU doctor, and the queue for the ED doctor as well. And I want you to record the average queuing times for each run in a file. And the model should also calculate and print the average queuing time results over the entire trial, over the batch of runs. I would recommend that you store the queuing time results for a patient in a pandas data frame, as I've just shown you. And that's stored in the model class as an attribute of the model. And that's basically calculated at the end of the patient's journey through the ED alongside their patient ID. So once a patient comes out the other side, it'll say, well, this is how long you spent queuing for the receptionist, this is how long you spent queuing for triage, etc. And then it bungs that into the data frame stored in the model. However, you may be saying, hang on a minute though, Dan, you've got a branching path here, which means that each of our patients will only have 3 queuing times, because none of them will see both the ACU doctor and the ED doctor, and you'd be right. So what you're going to need to do, there's different ways you could handle this. I would recommend this as being the simplest way, because it means that you're going to have a missing queuing time. Either this one or this one is going to be missing for each patient. I would recommend you replace the missing queuing time, whichever one is missing. If they've gone to see the ACU doctor, then the ED doctor queuing time will be missing, because they didn't queue to wait to see them. With a nan value, which you may have come across before, is basically indicates not a number. Now, there's a handy little shortcut in Python, which allows you to create a not a number, a valid not a number value deliberately. And the way you do that is you cast the string nan as a float. So you've seen, and used to using casting before, so where you're grabbing in a string from input from a user, and then you want to cast it as an integer, for example. Same principle here. You're going to cast the string nan. If you cast that as a float, Python will then automatically create an actual not a number entry. And the reason you want to do that is because nans are ignored by pandas when calculating things like the mean of a column. So you can then just calculate the mean of a column, and it will automatically ignore all those entries where a patient didn't queue for the ED doctor because they were queuing over here. So it's an easy way that you can do that. I also want you to deal with the branching path by having attributes in the patient class, so properties of the patient, that will store the probability that a patient goes to the ACU, and also some sort of Boolean indicator indicating whether this patient is going to the ACU, and a method in the patient class that will work that out. So the patient is going to have a 20% probability of going to the ACU, and they need a Boolean attribute that will indicate, is this patient going to the ACU or not? And in order to work out whether that Boolean attribute should say true or false, you're going to need a method. And that method I want you to do as a method of the patient. So the patient will now have a method as well as the constructor that will determine whether or not they're going to the ACU. Now, remember, you've already seen how to do this, how to determine whether they're going to go in one direction or another. But you're going to put that as a method within the patient class. And that method should be called after the patient is created. So basically what I want you to do is, when you create a patient, you'll give it a patient ID. You'll also give it a probability that it's going to go to the ACU. And then straight after you've created that patient, I want you to call this method of the patient that says, I'm now going to work out whether you're going to end up going to the ACU or not. And then that method will then update that piece of information that the patient holds. So you're essentially working out a predestined route for the patient. When you create the patient, you're going to say, are they going to go to the ACU or not? And then that patient will then carry with them that information, so that when they get to this branching path, somebody will ask them and say, are you going to the ACU? And they'll look at their piece of paper and say, oh yes, I've been told I am going to the ACU. And they'll go down that path. So that's essentially the way I want you to do that. Make sure you include the warm-up period as I specified above, and make sure that your results aren't stored in the warm-up period. So the first 24 hours of simulation run should not be storing any results. You can count patient journeys that started within the warm-up period but ended after the warm-up period, so you can count those. Don't forget to ensure that your simulation runs for the warm-up period also include the warm-up period and the duration after. So I want you to run it for 48 hours after a 24-hour warm-up period. So you're going to run for 72 hours in total. 24 hours of them will be the warm-up, and then 48 hours after that, we'll start storing the results. Right, what time are we? So I would recommend you take a 5-10 minute break, stretch your legs now. I'm going to split you up into groups. I would strongly recommend you work in those groups, because this isn't a trivial exercise, as you can probably see, but you can do it. And I'd recommend you refer to the SimPy 3.py file from the last session, which will have some of this code in for you, although it'll be in the wrong form. So that'll help you get started with that. Any questions? Good. Okay. Stretch your legs, 5-10 minutes, and then I'm going to give you tentatively an hour and a half to do this. So about 12:15-ish, we'll come back, but I'll float around the breakout rooms as well, just to see how everybody's getting on. You might fly through this much quicker, but I just want to make sure I give you enough time. Great. Let me stop the recording, and I'll put you into breakout rooms. But do stretch your legs for 5 minutes, because it's a long exercise you've got. Fantastic. Yep, see that?
Can you see that? Yep, okay. Okay, I'll try and talk through it. So imported the usual bits and pieces, and then set up the global class with the inter-arrival times and the means times for each of the activities, and then also the probability they'd be going to the ACU after the nurse. The number of each of the resources, the time for the warm-up period and the actual simulation, and the number of runs. And then we actually added in, this was later on after we'd tried it the first time, we added in a bit here, which basically means that if you sort of change the numbers around, so if you find that there's a bottleneck at the ED doctor point and you add a doctor, then it will, and you then save it to a new CSV, it won't overwrite the one you've done originally. And we've added it in here so that it tells you sorry, whatever you change it to, it's saved as ED, and then however many ED doctors there are that you've chosen, and however many ACU doctors, because that's what we were deciding that we were going to change. Then we added the class for the ED patient with all of the things that it needs, so the ID, the time with each of the resources. In here later on, we put the NaN in here because we realized that we could put it later on, but we may as well automatically set it to NaN and then just change it if they do go down that route.
That's a much better than in my solution. So yes, I agree with that.
So that was Kerry's suggestion, so I'm not taking credit for that.
Oh, not Kerry. She's much better code than me.
And then, yeah, the probability that they go to ACU, and then initially setting it up that they don't go to the ACU, so setting up as both, and then setting up the method to determine whether they do go to ACU or not, if the random number between 0 and 1 is less than or equal to the probability that we've set up here, which is 0.2, and then obviously it changes to true if it is less than 0.2. Then we set up the ED model class, which has normal stuff, the environment, the patient counter, all the bits about the resources, the receptionists, nurses, and 2 types of doctors, the run number, and then the mean queuing time for each of the 4 resources. We then set up the data frame to record the queuing times for each run, and set the index to be the patient ID. Then we did the generator for the process, or the arrivals. So you add 1 to the patient counter, and then you create a new instance of the patient, and then this is where you make the decision about whether or not they will go to the ACU eventually.
Fantastic.
And then get the environment to run the process using that instance of the patient. Sample the instant arrival time, and then wait until the time has run out before you bring another patient in. We then have the process that the patient will go through. So starting the queue for the receptionist, getting the receptionist resource, then when you have it, working out how long they were in that queue for, and then that sort of part of the process over, and kind of repeating the same thing for the nurse. And then when you get to the sort of split, just have an if statement to say if they are attending the ACU, then do the same sort of process but with the ACU doctor, and if not, then do it with the ED doctor. Yeah, so this bit here that we've commented out was where we originally had the bit about the NAN.
Yeah.
But we thought that you could do it here so that you could do it more easily.
That's much safer as well, I think, doing like that.
Yeah. And then to add the data to the data frame, we knew we needed to only do it if it was past the warm-up period time. So we set this little if statement, and then you add in the details about the queuing time for each part of the process. And then you calculate the mean queuing times for each run, I think. And then you write those to the file, and then start the generators and run the simulation for the warm-up period time plus the simulation time. Calculate the mean times, write the results, and then here you're just calculating the times for the mean queuing time for the overall trial, similarly to what was in the example. You got the calculation of the mean queuing time for all 100 runs, and then printing those out, and then writing the results to a CSV file, and then print. This bit is
so that's where you're doing your runs.
Yeah, sorry, yeah. Oh yeah, that's where you do the runs, it tells you what to do, and then calculating the overall trial results.
Fantastic. Thank you very much. That was brilliant. And what did you find incidentally? So am I right in saying that you found there was a bottleneck at the back?
So we found that the time increased quite significantly for the waiting time for the 2 doctors. So if you increased the doctors, I think, to the number of ED doctors to 3 and the number of ACU doctors to 2, then there was quite a big improvement. Although it wasn't under the 60-minute mark, so I think you had to increase it to 4 ED doctors and 4 ED doctors and 2 ACU doctors to get under 60 minutes, I think.
Brilliant. Yeah, I mean, that's the beauty of building a model like this. Once you've got it all built, you can really easily test those different scenarios. And really nice tip there about the file name. So we've mentioned a few times in the training about F strings. There's an example of an F string there on line 27. That's another indication of why they're so useful. So it's worth, if you haven't already, having a look at F strings, because they are incredibly useful things to use, particularly here where you're essentially using it to really easily put together a custom file name depending on what you're setting up. So that's really cool. Brilliant. Thank you very much. That was excellent. So I'll post the official solution as well, although as that's pretty much it. It's a slightly better version actually than what I did. Now there are two things that I'm not going to have a chance to go over properly because I've got 4 minutes. Fortunately, I did preempt this and recorded a couple of bonus tutorials, which I'd like you to watch. But I am going to attempt to just in the next 3 minutes very quickly show you at speed these things, and then I'd encourage you to go and have a look at the videos where they're not particularly long, they're about 15 minutes, just to have a little look at how you do these things, because these things I'm just going to mention now are particularly important for the sort of things you'll be doing. So let me just share. Right, so this, don't worry if you don't follow all of this, just get the basic principle behind it and then go and look at the video where I explain this much more slowly and in much more depth. First thing is something known as priority resource. So so far all you've been doing is having people queue and then they're basically seen in the order in which they arrive. But of course in a lot of problems in healthcare and in policing as well, you're not going to see people in that order strictly. You're usually going to also have some sort of priority system. So yes, you may see people who come in first, but you'll also be segregating on priority. So you want to see higher priority people, particularly if you're modeling an ED or something. That's the whole point of doing the triage. So there's a really, really easy way to do this in SimPy. And basically what you do is you use, rather than a standard resource class, you use something called a priority resource. So in this example here, I've got my receptionist and nurse set up as standard SimPy resources, but you'll see my ED doctor and ACU doctor are set up as priority resources as a separate class. And into those, I pass the environment as I did before and the capacity as I did before, but because they're priority resources, we can use them to deal with our entities that are coming through according to their priority. And basically what we do is we allocate a number, which is an attribute of that entity. So I've got ED patients, and I've added a little, I've called it priority. It could be called anything you like, but I've called mine priority here, and I've given it the default value of 1. Basically, what the priority resource will do is it will see entities according to whatever value we use to determine their priority. And it's an integer value, and the lower that integer, the higher the priority. So priority 1 would be low, obviously, but if somebody then came in with a priority 2, the priority 1s would be seen before the priority 2s, even if the priority 2 had come in first. So it allows you to really easily do that. So in this example, I'll go through it more in the video, but I've just got a method down here. All I do here is just randomly select a priority for each patient between 1 and 5. But obviously, if you were doing this in reality, you'd have something a bit more detailed. So you might have, a certain percentage that are a certain priority or something else. But essentially, you're just setting up this priority number and using a priority resource. And then when it comes to actually calling that resource, so if we look down here, where I'm now requesting an ACU doctor, I do exactly the same as before. The only difference is I also include a little input in the brackets, which basically tells me what value to use for the priority. So you say priority equals, and then whatever value you're storing that entity's priority in. So I called mine priority. So my value would be priority equals patient.priority. So in other words, I want an ACU doctor, but see me in priority order, and I want you to base that on the priority value I've got stored against me. So it's really simple to do that. And in the video, I'll show you that when you run that, you'll see patients that will come in after other patients, but have a higher priority, will get seen first. So that's really, really useful for a lot of the things that I suspect you'll be modeling, that you'll have some sort of priority. But it's as simple as that. You just have a priority value. You have a priority resource instead of a standard resource for any queues where you want to use priority, and then you just tell it to use that priority value to do that. So it's really simple. And the last thing, just for a quick break for lunch, is unavailability. So you may want to model the fact that your resources are not always available, that they may be on breaks or they may be called away to do other work. And you can do this really easily. I think we mentioned this briefly maybe last week. And the way you do that, you can just set up another activity, another function that basically allows you to obstruct your resource. So let's imagine I wanted to obstruct the ED doctors to say that for certain amounts of time they'll be unavailable. Then I can set up a separate method called obstruct ED doctor. And basically what this will do is it's a generator function, just as we've seen before. And it'll freeze that function for a certain amount of time. But then after that time, it's going to request an ED doctor, and it's going to request it with priority -1. So I'm using a prioritized resource. And by using -1, I know this will get the highest priority. So in other words, the doctor will finish doing what they're doing with the current patient, but then after that, they'll be broken away. And so basically what this does is it just keeps the ED doctor unavailable for a certain period of time. So in this example, and I'll go through it more in the video, I've set up a frequency and an amount of time. So this basically says every 8 hours, every 480 minutes, remove the doctor for 240 minutes. And you could have those as fixed values. It might be that you have fixed break times, for example, or you might want to put some sampling around that. You could do either way, but the principle remains that all you need to do is essentially just set up another activity that uses the ED doctor with a highest priority, so it'll grab them as soon as they can before anybody else, and it will take that resource out for a certain amount of time. And you can model unavailability really easily just doing that. But as I say, that's a 2-minute explanation of that. Have a look at the bonus videos. If you go onto the YouTube channel, on the bonus tutorials playlist, you'll see there are 2 bonus tutorials. One's called SimPy Priority Resource, and the other's called Modeling Resource Unavailability in SimPy. Have a watch of those where I'll go through those things a bit more slowly and show you working, so you can see that. But they are particularly important for the kinds of models that you will likely be building. Brilliant. Okay, let's pause there because we spilled into lunchtime a little bit. Anybody got any questions just before we stop?
Could you use the similar thing to model the availability of doctors in so much that they work shifts and there usually overlaps on shifts, so the available number of doctors won't change by the hour anyway?
Yes, so you could do that. So you could say, well, I've got 3 doctors available, but there'll be an overlap here where I've got 4 doctors for half an hour. So yes, you could do that. So it's the same principle, basically. And it's quite a common thing that you're doing in modeling where essentially, if you think back to the very first session, we talked about things you want to simplify. And very often you don't want to, model in detail the doctor going to their break room and having a cup of tea, but you do need to model the fact that what's the impact on your system? The impact is you've got 1 fewer doctor for an amount of time, or as in your case, where you've got an extra resource for a certain overlap. And so you just model that as simply as you can to say, okay, well, give me some extra resource for that amount of time, or take away some resource for that amount of time. And that's the simplest way to do that, to essentially model your resource being taken away for an amount of time.
Okay, thank you.
Did you say that priority was an integer value?
Yes.
Okay, because I guess you could have priority as a function of time, and so people who are there longer move up the priority list.
Yep.
But yeah, I guess you can still do that even though it's an integer value. You just round it to the closest integer.
Yeah. Whatever function you want to use to determine their priority, you would then just scale it on an integer scale. So yeah, that allows you. There's no max limit, or you can do a minimum either. So
Okay.
so you can scale them however you like. They just need to be integers. That's all.
Is the same true for the perverse behavior of we're reaching the hour limit up their priority? effectively. Is that what was just said? No, misunderstood.
Yeah, you could. So yeah, so if you're modelling the sort of ED and you're getting close to the 4 hours, and then suddenly their priority would go up. So yes, you could have like a function that determines the priority dynamically, and it's inverted. It's kind of the inverse of the time they've been in the. So yeah, you could do exactly that as well. I mean, the beauty is you can do anything you like. I mean, so obviously in the example I've used, I've just randomly set a number between 1 and 5, but that logic could be anything. And because you're modelling dynamically over time, you can have those time effects. You can say, well, you know, if a certain amount of time has passed, then it changed this priority level. Brilliant. Okay, let's pause there to make sure you've still got a decent lunch break. So that's the end of the discrete event simulation sessions. And if you have any questions, obviously let me know on Slack. But my key message would be to, well, first of all, go away and have a look at those 2 videos. They're not very long. And the second thing would be to practice, have a play around. You're all doing really well. I mean, the models I've seen you build this morning are fantastic. It's I think a lot of you've really got on really well with discrete event simulation. So keep practicing at it. And I know a number of you will be using it for your projects. So yeah, have a good practice, and it'll serve you well going into those. So 1:30 we'll be coming back. It'll be a different Zoom login because Tom's taking this afternoon session on forecasting. So make sure you have a look at the module 12 channel where he's posted the Zoom details, and that'll be kicking off at 1:30. Brilliant. Thank you, everyone. And
Thanks, Dan.
cheers, guys.